Okay, so this is demonstration video 1 of B04, our introduction to Python. Today we're just going to look at a simple use of the Python prompt on the cluster. So if you're looking here where I'm logged into the cluster, I'm just going to type in Python 3 is the one I'm looking at. If you do Python and just tab, you'll see a range of Pythons appear, different Python versions there. We're looking at Python 3. This Python 3.9, if you want, is pretty much the same, whichever one you choose. And you can check which one you're using by typing which in Python 3, and it'll point to that version, which is my local version. And then I think the Python code to say which version it is, it's 3.713. If we want, we can use Python 3.9 as well. So what we see here is that there's a command prompt at the start with 3 greater than symbols, and then you type code here afterwards. So if I want to do something simple, like ask it 1 plus 1, I can do that, and it will respond with 2, indicating the determination, the outcome of that calculation. If I do 11 divided by 123, it will answer that as well. I can, for instance, write a function, use the function round to round that number by using round brackets. So I'll just put spaces in here so you can see it better. Round bracket at the end, and that will round that number to the whole integer, which is 0. Or maybe we might want maybe 3 decimal places. So I'll use that as a second argument there. So we have 2 arguments, 11 divided by 123, and the second argument is 3. Then we see it's 0.089. There's other ways of doing this as well. So we can assign a value x is equal to 11. So now if we say x there, it'll say it's 11. If I say print x, it'll say 11. If I say print x multiplied by 2, it'll say 22. If we say print x to the power of 2, it'll say 121. We can create another number as well. I'm going to call it t. I'm going to assign that a value of 123. In the same way as if we say x divided by t, we'll get 0.089 again. And in the same way, I'm just going to use the cursor keys to go back through my code because I'm lazy. I can type in here and remove the scalars x and 123 and put an x divided by t, and then I get 0.089 again. And I can toggle that as I see fit if I want to look at other outcomes like t divided by x. So we can see that when we define a variable, we just type in the variable name. Let's call it name1, and we use the equal sign to assign that value of 55, and then that name1 becomes that value all the way through. However, if we reassign it to 556, name1 is now permanently changed to 556. It is not 55 anymore. We can add text when we print out things as well. So sometimes when we're writing a proper script, it can be useful to say, if we're debugging especially, x is something. So we use space, have a space at the end, and then we put in a comma because we're going to put in more things. We're going to put in that variable x to see what it is. So we put in x at the end. So x is a special character, it's a variable. So it's separate from the rest of it here. Normally in Python, we have a space after the commas just for cosmetics. And if we type that in, it will say x is 11. If we leave it without the space, it still works. But when you use PyCharm is a bit finicky. And then we can do x is x, comma, space, and t is, comma, t, like that. And it'll say x is 11 and t is 123. We can adjust that for the spaces if we wish to do so as well. Everything is adjustable. And if you want something more complex, t to the power of x, we can do that too. So we do functions within those expressions too. So you can see that there. E is for an exponential number, obviously. Final thing is that say we want to type in I pressed Control C to interrupt what I was doing, to type in you're using Python, and maybe I want to put in the apostrophe because I'm pedantic. What I need to do is put in a special character, which is a backslash, and then I put in the apostrophe. If I don't put in the apostrophe, Python will think that it's the end of the string of letters that we have here. So this will print it out properly. If I remove the backslash, let's see what happens. Oh, it worked this time. If I put in two, okay, if I put in two apostrophes, what will it do? It keeps them. Okay, that's good. That's useful. So yeah, that was one of the other things. So there's a range of functions in Python as well as creating strings and characters. So we can have different things that are used. We can have, let's say, 33 mod 4 to use get the modulus to get the remainder, which is going to be 1 there because you've got 32 is a factor of 8. 4 by 8 is 32, so you have 1 left over. That can be useful if we're counting codons, for example, or counting certain things. And there's other things. I give you the example of the input function in class. So input, we can just say to ourselves, please give me a number. The text can be anything here, but it's just looking for input. If we do that, we just give it a number and it will complete that and give us back 5. We can make it more advanced by going to the start line. That's called an int for the time being. And we're going to assign this value as being num1. Oh, I use the Perl, the R assignment. So it's equals. So give me a number minus 3. Now we say, what is num1? Num1 is minus 3. I can even be more elaborate. Num1 is, comma, num1. And it will print it out for me. So this can take on board different numbers. It can take on float numbers in the same way. So let's change num1. We're going to change it to be a floating number. So that has a decimal point. We'll run now 3 point whatever. And then we ask again, what is num1 now? Say 3.456. So you can try some questions yourself. For example, you can try this special command. What does x power multiply asterisk equals 4 do? What does that do? That's part of the questions in the tutorial. And then one of the other things is to print out the new line character. So \n prints a new line, as you'll see there. And we can put it around 2 new lines like that. So we have here and here too. We have new lines at the start, end, and middle of them there. So we can move on to lists now. We can create an empty list called empty1 with nothing inside. And what we're doing is creating it with square brackets. So square brackets define a list. If we ask what's in empty1, nothing. We can reassign it and maybe add some numbers in there. I'm going to add 1 and then 33. So there's just 2 elements in there. And when we ask what is inside empty1, we can see that there's 1 and 33. We can use the square brackets to access elements within empty1. But note, if we ask for element 1, that is going to give us the second element because empty1, Python, like most coding languages, starts counting at 0. So we need to go to the 0th element, which is 1. So let's redefine empty1 to have a range of characters. So you can see what's inside there. So we have 99 at the end. So if we access element 0, it's still number 1. If we access element 1, it's second element 33. If we go to element index 2, it's 44. The third element, index 3. The fourth element, 788. We can then do calculations with these if we want to as well. So you can divide 788 by -1. Oh dear. I forgot to put a 1 in here. So what it's saying there is that empty is not defined. So what I want to say is empty 1. There we go. We got minus 788 there. There's variations on this as well. So for example, if we want to append things onto the end of MT1, we can do that. So maybe I want to append the digit 6 onto the end. And now I'm going to check what's in MT1. You see that we have the digit 6. Another way of accessing the final element in MT1 or any list is to use -1. This gives us the very last element. So if we have a gigantic list, this can be handy just to find out, oh, did I go from A to Z or did I stop at Y for some reason? -2 gives us 99. -3 gives us -1. And then I think if we have 7 elements, -7 in fact gives us the first element. So we can count backwards as well as forwards. And that can be, again, that can be quite handy when you have a gigantic list and you're confused as to what actually worked and didn't work. So there are more functions. Let's take MP1 and insert. We're going to insert a number, maybe the second element. So this is going to be, if you get me, this is going to be the enter after 0, 1, 2. It's going to insert there as 2 and then push the other ones further down. It's going to be 133, our new number. Let's call it 888. So we'll see it. And see what's inside MT1 now. So you can see there we've inserted that number. So 44 is no longer the third element. And we can access 888 by just requesting for element index 2, and we get it back. Okay, maybe I'm sick of element 888, and I can specifically remove that. And this will actually go to the correct index at element 3. So if you check back now, what's element 2? It's 44. So element 88 has gone forever. You can check the structure of MT1 again to visually confirm this. So you can see we lost 888. The same work for strings. So if we have a range of items in here, let's call it A, BB, and CCC, we can check what's in var1. And what we can do is let's extend var1. So var1.extend, and we're going to add onto it empty1. So mixing strings and numbers maybe not the best idea, but it's just the illustration that we are adding A, BB, CCC, and then our string of values in MT1 are there now. We could also use the function pop to remove the last element in our new extended var1, and that can be handy when you're using a loop to iterate through a series of values. So pop, we lose 6. Let's check var1 now. 6 is gone. So 6 is returned by pop, and that can be helpful when you're processing data to know that, say, a sample has been read and modified and then printed out or something like that. Another one is to check var1.index. Do I have BB in here? And it will say 1. It's at 0, 1 here. If I say CCC, it will give me the index 2. Oh, CCC. So it says CC is not on the list, which is correct. So that can be handy as well. If you have a big long list, you're saying, is my gene of interest on that list? You can check it there. So it says, yes, it's element 2. If we have something, so let's var1.append. I'm going to append at the end 44. We're going to do it a few times. We can then ask it to count the number of instances of 44, and that's a very convenient function. So you see it's 3 times there. And we can ask as well, what's the index of 44? You see, we've one index at 5. That's the first one, I think. 1, 2, 3, 4, 5. That's the first instance. So it doesn't give all of them because we have 2 at the end as well. We can also, let's append things onto here, this list to illustrate. Add things onto the end. Oh dear, I forgot my quotes. You'll see the errors are a bit unclear, but it's saying EOL, end of line, while scanning string literal. So it couldn't find the end of the line, is what it's trying to say here. Let's append on AA and AAA. var1 is now this. So now we can print var1.sort. Oh, I'm mixing ints and string. So what we can do then is just create a new string. Let's call it var2. Placement didn't work. Let's give it a list to sort. So we have our var2 there. So we just say var2.sort. And we get our sorted list here, AACVXX. We can reverse this using the command reverse. And now look at var2, we find that it's reversed. And then the final one, I guess, is that you create a var3 if you var2.copy. But again, that's kind of, I'm not sure how useful that is in reality, because if we just do var2 equals and send that to var4, var4 is the same thing. So it's just multiple ways of copying. So that concludes this demonstration video.